Hi, this is Doug Tidwell for Gradle Enterprise. Over the next 10 minutes, we'll talk about developer productivity, developer joy, and how Gradle Enterprise makes those things happen. As we talk about developer joy, think back to when you started writing code. Most of us started out like this. We had a simple piece of code, and we ran it, and we got developer joy. We got instant feedback that let us know our code worked, and as we changed the code and added things to it, we got instant feedback on our changes. Life was good, and we decided to pursue a career in software development. Now most of us are here instead. We start a build and test cycle, and it runs for several minutes, or half an hour, or more than an hour. We're not getting instant feedback, and when we finally do get it, it's not always useful. And there's a good chance our minds aren't focused on the problem anymore when that feedback does come back. This is not developer joy. We need developer joy because happy developers write the best code, and happy developers are focused and productive. That's vital because software is working on society's biggest challenges. It's also an enormous part of the world's economy. IDC estimates that almost 2/3 of global GDP is based on software. But as we all know, building software isn't easy. If our developers aren't productive, just throwing more unproductive developers at the problem won't solve the problem. To create happy developers, we need developer productivity engineering. DPE is a software engineering discipline that delivers faster feedback cycles, better feedback, and developers that are focused, productive, and happy. Part of that discipline is a set of technologies that make builds faster, sometimes as much as 10 times faster, and part of that is better data about our builds. And of course, analytics for that data as well. Over the last few decades, technologies have come along that changed the way we do business forever. At Gradle, we see DPE as the biggest change to software development since the rise of DevOps. To be clear, DPE doesn't replace DevOps, it complements it by reducing the friction of building and testing software. DPE makes DevOps even better. We built Gradle Enterprise to deliver on the promise of DPE. We'll take a quick tour of the product, starting with build scans. A build scan is a centralized and shareable record of a build that includes logs, diagnostics, performance metrics, and failure analysis to give us feedback to find and fix features that fail. We can compare build scans to see any changes between builds. Failure analytics help us track down tests that keep breaking. If a test fails, we can see how often that test has failed. Does it only happen on a particular day or for a particular user or machine? Failure analytics can tell us that. And test insights give us even more, insight, making it easy for us to track how stable our code is, whether that's across our entire organization or looking at a single code branch. Those are the highlights, so let's get started on the tour. This is a list of build scans from the Micronaut project. Micronaut.io is a framework for building microservice and serverless applications, and it's one of a number of open source projects that rely on Gradle Enterprise. Even better, they make their Gradle Enterprise instance available to the public. Anyone can visit ge.micronaut.io to look at build scans, failure analytics, test insights, and other things. This is a successful build scan. We see an overview of the build here. The entire console log is captured as well. You can see here that there were some error messages, even though the build as a whole was successful. The build used some deprecated methods. We can see those here. And we can also look at the infrastructure used for this build. That includes the operating system, Java version, and username, among other things. That was a successful build, but obviously there are failed builds as well. When we open one, we can see highlights of the failure on the overview page. There's an explanation and some lines from the console log, but best of all, there's a failure history. Following the link to the failure history shows us the failure analysis page with the history of this particular failure. We can see that over the last 7 days, this failure has occurred 44 times out of more than 21,000 builds. Graphs show how many times the test failed on each day, as well as the users and hosts involved. For even more insight, we can scroll down and see the list of all the failed builds that fit this pattern, and we can click on any build in the list to go directly to its build scan. That's an enormous amount of historical data that's been analyzed and organized for us. Gradle Enterprise also features test insights. Looking at this page, we can see how many builds have failed tests. In this example, about 550 builds out of 6,500 ran tests and had a failure. Obviously, a build can fail before it ever gets to the testing stage. That's why these totals are lower than the 21,000 we saw in the failure analytics page. Beneath the graphs is a list of tests that failed, initially sorted by how many times it failed. We can click on a particular test and get historical data about when it failed and how it performed, and we can even drill down into the methods of the failed test to see which ones fail. Here we can see that the failing test class has 4 methods, only one of which has ever failed. We can also look at flaky tests. Drilling down on those works the same way. We'll click on a particular build scan to see what happened. In this build, a test ran twice. The first time, it timed out after 30 seconds. The second time, it worked without any problems. That's a flaky test, and it's something we're going to have to figure out before we go to production. Gradle Enterprise gives us the tools to track down the error. Starting with Gradle Enterprise 2021.4, much of this functionality is available for Bazel builds. Gradle Enterprise uses the build event protocol to create build scans for Bazel. Here we filtered the display so that only Bazel builds show up. Most of them were successful, but a few failed. Here's a successful build. We can look at the console log, see which tests executed, which targets executed, and get details about the options used for the build and the infrastructure it ran on. This build ran over 200 actions and 1,100 tests, and we can see that none of the actions came from the cache. Now here's another successful build. This build ran only 1 test. Looking at the console log, we can see that almost all of the tests were cached. If our code hasn't changed since the last time we tested it, there's no reason to test it again. Now let's do a build scan comparison of the 2 successful builds. The custom values and infrastructure were the same, but there are differences in the options used by the 2 builds. Scrolling through the list, it looks like one build was done on Java 8 and the other on Java 17. Without easy access to build scan data, that's a difference that might take you a while to spot, especially since both builds worked. Now let's look at a failed build. Here we can see that one test failed. Clicking on the test takes us to the console log, which shows us that we had a server configuration problem. The test needed a port that was already in use. That tells us we need to look at our build machine, not our code. Hopefully at this point you've got an idea of just how much time, toil, and tears Gradle Enterprise can save you. We encourage you to visit Gradle.com for a free copy of the DBE Handbook and follow this QR code for our DPE homepage. Thanks so much for watching. For Gradle Enterprise, I'm Doug Tidwell, saying may all your bugs be shallow. Cheers.